All right, so we're going to go through and we're going to calculate our new freezing point. So remember, when we add solute to a solvent, we see, depending on the solute, a temperature change. So either it raises or lowers. So it's either going to lower the freezing point, it's going to raise the boiling point. So we're going to go through and say, well, what would be the new freezing point? So again, we're talking about freezing point of a solution if we're adding 24 grams of strontium hydroxide and we dissolve that into 200 grams of water. So we're trying to figure out, well, what is water now going to freeze at? So we should know that water freezes normally at 0 degrees. Okay, so if you weren't aware of this, you can look at our chart and we can look at water's normal freezing point and say, okay, it normally freezes at water. Okay, so if you didn't know that, you could always reference the chart. So we're trying to figure out when we add this strontium hydroxide, what is it now going to be freezing at? So again, it normally freezes at 0, but if we add strontium hydroxide, which is a solute, we should notice a freezing point depression. So we should notice that the freezing point is lowering. So first of all, we know we're using our freezing point. So we know that we're using our delta TF. Remember, delta just means change in, equals KF times M. And then if we look, we should notice that strontium hydroxide is an ionic compound, so it's one that is going to dissociate. So if we take that and we multiply it by I, so we can include the number of ions. So we're going to go through and we're going to figure out our different variables. So I'm just going to make that a capital M just so it's a little more notice. That's our molarity. So we're going to go through and we know our molarity equation is moles over liters. And remember, our moles is a solute, the liters is our solvent. So we're going to go through and we're going to plug in each piece of information. So we know we have 24 grams of strontium hydroxide and 200 grams of water. Well, this one's easy because we know that water is always the solvent. We weren't sure which one we're putting into liters, so again, remember liters is of the solvent. So if we weren't sure which one was the solvent and which one's going into the spot for liters, since they're both grams, you can always go check your chart. So these are all solvents, so you want to look and find out, well, which one is listed on the chart, because that's the one that has our specific freezing point or boiling point that we're using. So we're going to go through and we're going to actually figure out, well, look, we see water on there, so water must be the one that's going into liters. So we're going to go and we're going to convert our 200 grams of water into liters. So now remember, just a heads up, so we know that 1 gram is equal to 1 milliliter. So if there's 200 grams, we can assume that there are also 200 milliliters of water. That only works for water. Okay, so just a reminder, it only works for water. So when we convert that into liters, we get 0.2 liters. Okay, so we have our 0.2 liters. Now we have to convert our 24 grams of strontium hydroxide into moles. So that's the one that gets a little trickier because we have to actually go through and find our molar mass. So we're going to take our 24 grams of strontium hydroxide and we're going to convert it into moles using our molar mass. And we have 1 mole of strontium hydroxide. Calculate that out and we get 0.019 moles of SrOH2. All right, so now we have our moles and we have our grams. So we're going to plug them into where it goes. Actually, it's 1.97. Sorry, we want to round that so it's 2 sig figs. Let me just fix that really quick. So we get 0.2 moles. So now we're going to go through and we're going to plug everything in. So we're going to take our moles, which we just said was 0.20 moles of our solutes. We're going to put that over our solvent, so 0.20 liters. All right, so we are going to go through and calculate that out. So that'll end up being 1. We want 2 sig figs, so 1.0 of our molarity. So now we have our molarity. Now we want to figure out our I. So we're going to take strontium hydroxide and dissociate this. breaks into Sr plus 2 plus OH minus 1. Balance it out, so put a 2 in front of there. So we end up getting 1 ion from strontium, 2 from hydroxide. So our I is going to end up being, so we know our I ends up being 3. Okay, we know our M, we just calculated, is 1.0 M. And then our Kf, remember, is always our constant. So we're going to go to our chart. We're looking at our Kf, so this column right here. Well, our solvent is of water, so we read over. All right, our Kf is negative 1.86. And we just want to look at our units so we make sure everything is correct. So degrees Celsius over molarity. Okay, so we have degrees Celsius is going to be our answer of our delta TF. So now we can plug everything out in. So our Kf is negative 1.86 times our M times our I. And if we look, all our units are going to end up canceling out, and you should notice that our N unit, because our molarity will cancel out because we have molarity on denominator, or as a denominator and as a numerator. So we're going to end up canceling it out. So our delta TF ends up being negative, because negative 1.86 times 1 times 3 gives us negative 5.58. And again, that unit's degrees Celsius because our M's cancel out and the I doesn't have a specific unit. So then we calculate it out. So we know our temperature is going to decrease by negative 5.58. Well, if we look at our normal freezing point is 0. So if it normally freezes at 0 and we're subtracting 5.58, so we're freezing at negative 5.58 lower, our new freezing point is going to still be negative 5.58. Again, that's only because it is 0 degrees Celsius. So when we take 0 and add that to negative 5.58, it still gives us negative 5.58. So our new freezing point is going to be the same. So I want you guys to try the next problem. So this one, again, just careful. It is a new boiling point, so we're using our other column. Okay, it says non-electrolyte, so kind of use it as information, and you guys can do that for homework.